So remember we talked about synthetic division, sorry, we talked about polynomial division, specifically our long division on Friday. Now we're going to look at the synthetic division, which is the other guy. Now, I tend to like long division more because it works for everything. Students tend to like synthetic division more because it goes faster. Which is why I cover both of them. As long as you understand that there will be some cases that you cannot use synthetic division. So we still have to know how to use long division, but we can use synthetic division when appropriate. So for synthetic division, so we still have to be in standard form with no missing terms. So that's the same for synthetic and long. Okay. Now, the key difference is this only works for divisors. What's a divisor? What's the divisor?
The number is
Which number?
the dividing number.
Yeah, what you're dividing by, yes? So like it's the one on the bottom if it's a fraction, or the second one if you have a division symbol. So it has to be of the form x plus or minus a. So we have to have something that has a leading coefficient of 1 and is to the first power. If it is not of that form, we cannot use synthetic division. Which is why on a couple of examples that we did on Friday, one of them we divided by like a 2x plus 1. Could not have used synthetic division. The other one that we did, we divided by an x squared. We also could not have used synthetic division. So synthetic division is helpful, but only when stuff is in that form. So if I had something like n of x divided by x minus a. On the inside, we are still putting our n of x. On the outside, I am just going to put a. So that's a big thing to notice, is that we flip the sign of the divisor. And another key important thing, because we have flipped that sign, we will add as we go down. And we'll look at some of the other steps here in just a second when we do an actual example. But they get really wordy, so that's why I'm just showing kind of the setup, and then we'll do the steps together. So, it says use synthetic division to divide x to the fourth minus 10x squared plus minus 2x plus 4 by x plus 3. Yes, no, maybe? So, first, are we in standard form? Like, do we go from biggest exponent to smallest exponent?
Yes.
Yes. 4, 2, 1, 0. That goes from biggest to smallest. Now, are we missing any terms? Yes. Okay. I think that might have been what you were thinking. But, so we do have to put in a placeholder for our x cubed, since we're missing it. The other thing we need to check is our divisor, so that's the second one, is it of the form x plus plus or minus a. Yeah, we're to the first power, we don't have a leading coefficient, and we just have a number there. So we're good. So then we have like our upside down. Okay. And then we are just going to take the coefficients. What are the coefficients?
The first numbers.
Yeah, so I'm just going to take each of these numbers, and that's what we're going to write on the inside here. So I'm going to write 1, 0, -10, -2, and 4. Are y'all okay with that? Do y'all see where I got those from? And that's what makes this go quicker, is that we drop all of our x's. So then, what number do I want to put on the outside?
Next verse.
So remember, I'm just going to put the a value. So again, I'm dropping my x. So what's my a value? -3, yeah, because we have to flip that sign. So this is just a set. So then, our first step is to bring down our first number. So I'm just going to bring down a 1. My next step is to multiply. So -3 times 1 gives us -3. Are we okay with that? And then we said, what operation are we going to use as we go down? We're going to add. Because remember, we've already flipped our sign here. So basically, it's like that's taking care of all of the subtracting that we have to do for long division. So because we've already flipped the sign, we don't have to subtract anymore. We just get to add instead.
Yay.
So 0 plus -3 gives us -3. Right? 0. I'm adding as I go down. 0 plus a -3 is -3. Are we all okay with that? Alright. Then I start the whole process over again. -3 times -3 gives us
Positive 9.
+9. We add as we go down. So -10 plus 9 gives us -1. -3 times -1 gives us
Positive 3.
+3. -2 plus 3 gives us 1. Lastly, -3 times 1 gives us -3 plus 4 gives us 1. This last number, I'm going to put a box around. That's going to be our remainder. But does that answer look like a polynomial answer? No. So just like I took out all of the zeros to set up my synthetic division, all of the x's, I have to put all of the x's back in order to have my final answer. Does that make sense?
Yeah.
Okay. So I need to convert all of this numbered stuff to like an actual answer now. So if I had an x to the 4th and I divided that by an x, how many x's am I going to be left with? 3. So I should have an x to the 3rd. So whatever the first number is, okay, that's what number is going to go in front of your biggest exponent. So 1, x to the 3rd. And then I'm just going to go down in descending order. So I have a -3. My next exponent going down would be 2. Then I have a -1. My next exponent would just be 1. Then I have my constant, which is 1. And then remember, just like we did before, I'm going to add my remainder over the original divisor. And that will be our answer. What questions do we have about like the setup, where we got specific numbers, or how we put it back together to give us our final answer? Okay. So now here's the question. If I took 32 and I divided divided by 3. What do we get?
What is it?
10 decimals.
10 with a remainder of 32 divided by, what did I say, 3, right? So what's the closest number that 3 goes into? That's smaller than 32. So does 3 go into 32 evenly? No. Does 3 go into 31 evenly? No. Does 3 go into 30 evenly?
C.
Yeah, 10 times, right? So we would have 10 with a remainder of 2. We're okay with that. So would we say that 3 is a factor of 32? If I got a remainder? No. What about if I took 32 and I divided by 8? What do we get? 4. Do we get a remainder? No. So would we say that 8 is a factor of 32?
Yes.
Yeah, we can say the same thing with our polynomials. So our factor theorem states that if x minus a is a factor of n of x, then n of x divided by x minus a has a remainder of 0. Makes sense, but it's nice to go ahead and write it out that it works the same way as it does with like our normal numbers. And this is also helpful because it helps us then be able to factor polynomials that we might not have been able to factor otherwise. So let's look at an example. So I asked y'all to show that x minus 2 and x plus 3 are factors of that big F of x. And then we want to find the remaining factors. So if I said that it is a factor, what should we get for our remainder? 0, right? It's not going to lie to you. It's not going to be like, show it's a factor, and then it's not really a factor. Bless you. Now, it could say, is this thing, so like, is x minus 2 a factor of this? Now, in that case, you could get no. But it's not going to say, show it's a factor if it's not. So, what's going to go on the inside of my synthetic divisor? That whole thing, yeah. So what are my coefficients?
2,
2.
7, negative 4, and negative 27, negative 2.
Cool. And then which factor do we want to do first? X minus 2 or x plus 3?
Minus 2.
Sure. So then what's going to go on the outside?
2.
Positive 2. Yeah, okay with our setup.
Sure.
And what do we say should be our remainder?
0.
0. So remember, first step is to bring down our 2. You should always draw that arrow first. Because if you start multiplying stuff from the beginning instead, it's going to mess up the whole rest of your problem. So then 2 times 2 gives us 4. And again, we do what as we go down? So 7 plus 4 gives us 11. 2 times 11 gives us, okay, plus negative 4.
18.
Okay, 2 times 18 gives us,
36.
let's say, negative 27. 9. 2 times 9 gives us 18, and negative 18 plus 18 does indeed give us 0, which is helpful. So now I had a 4th degree, I divided it by a 1st degree. What should my answer then be? What should the degree be?
2x to the third.
Yeah, I'm going to have 2x to the 3rd plus 11x squared plus 18x plus 9. With the remainder of 0, so I don't have to write anything this time. Yes? So that means that we know that our first factor for f of x has to be x minus 2. Are we all okay with that? And we're trying to find all the factors. Yes? Okay, but do I know another factor? Okay, what's the second factor that they give us? X plus 3. Now, be careful, because technically we could take x plus 3 and we could divide it back into my original, and you would also get 0. Yes? But that doesn't help us find the rest of our factors. Okay, so we want to take what we just got as our answer, and we want to factor that now. Are we all with me there? Because we're trying to like keep making it smaller and smaller and smaller, so we find all of our factors. So this time, on the inside, I'm going to write this one. So 2, 11, 18, and 9. And we're divided by the x plus 3 this time, so what goes on the outside? Negative 3. So I want you to do this one on your own. So what should we have gotten as a remainder again?
0.
0. So what's my first step always?
Bring
Bring down the 2. So negative 3 times 2 is plus 11 is 5. Times negative 3 is 3. Negative 3 is negative 9. So we do indeed get 0. So now, what did we know our next factor is?
X plus 2.
Okay. Now they didn't give us another factor, but remember that this is technically, right, I had a cubed, and we divided it by an x, so what should this degree now be?
2x squared plus 5x minus 3.
Plus 3. But yes. Okay, so that's going to be my other factor. that goes here. Because now this is a quadratic. Do we know how to factor quadratics? We should. We've done it quite often. So I'm going to do what in order to factor?
Divide everything.
Yep. If you wanted to go off to the side to do it and then just put your answer in, that would be fine. I'm just going to do it. So 2 times 3 gives us 6. What multiplies together to give us 6? That adds together to give us 5.
3 and 2.
3 and 2. So then what can we factor out of our first 2?
2
And we're left with x plus 1. And then we can factor out a 3 from our second 2. And we're also left with x plus 1. And now we have it in completely factored form. What questions do we have on that? So then if I asked you to solve this, what would we do with each of our factors?
Set equals 0.
Cool. So if I set x minus 2 equal to 0, what do we get?
2.
If I set x plus 1, or sorry, plus 3 equal to 0, what do we get?
3.
Negative 3, yeah. If I set x plus 1 equal to 0, we get, and then if we set 2, was it 2x plus 3?
Yeah.
2x plus 3 equal to 0, what would we get there? So we would subtract 3,
Negative.
45. Negative 45.
Negative 32.
which is also negative 1.5. Either one is fine. Yep. Bless you. So how many answers did we get?
4.
4. What was our degree?
4.
4. So does that make sense? Could I have gotten 6 answers? Can I get more answers than what my degree is?
No.
No. So 4 makes sense. Okay. We could have gotten 3 or 2. That would have been okay as well. But we couldn't have gotten more than that. Do we have any questions there?